Hello everyone, good morning. We'll wait for a couple of minutes for others to join. We'll start shortly. Okay, can you please confirm if I'm audible? Is it clear? Okay, thanks. Now, okay, let's get started. So last time we have seen couple of methodologies on map function and filter function. We'll continue from there. So there is one more function which is called as reduce. So what reduce does is this processes a sequence of elements into a single value. For that, you have to import a library which is import on tools as FT. Now, this is the library we have to import, and let's say we have a list. Like this, we have a list, and in this list, let's say we define a function like this, and return f1 plus L1. Like this, we are defining a function, and let's say that if we do something like this, if we do the sum will be ft dot reduce. So what we are trying to do is we are trying to use the reduce method that will return a single value. We will pass this function and will pass the list like this. The sum is column, comma sum like this. So if you run this, here you can see the sum is 303. So all the numbers are actually summed up and reduced to a single value. So this function is actually applied to all the items of the list, and it reduced a single value. Like this, you can write any kind of function, and it will always return a single value. So that is the usage of reduce. Now let's say that I want to square all elements of a list using map and lambda. So we'll write a small function, square all elements of a list using map and lambda. So lambda we have discussed, like it is a one-liner anonymous function that returns a value. So let's say we have a list, like this we have a list, and we will do the multiplication. So we are using the map function, correct? Map will apply this method onto the iterator object, and here we are using inside map, we are using a lambda method. X is to x into x, comma, and underscore. If you see over here, what is happening is we are mapping this, we are passing inside the map function this lambda, okay, and on the list. So for all the items of the list one, all the items are getting squared using this lambda method, and this map is applying this method onto all items of the list. So that's how you have to read. So map is actually applying this method onto all items of the list, like this. Next is, next topic which we'll be discussing is classes. Let's see if you have any questions. Okay, no questions. Okay, so now Python is a object-oriented programming language, and it means that object-oriented programming is a programming methodology where object represents data and methods, and this helps in creating something called as reusable code, similar to functions. We have a classes, and classes contains various objects. So what is a class? So a class is actually a blueprint of object that explains certain attributes and behavior. So a class is a blueprint of object or instances that explain certain attributes and behavior. Okay, now we'll see that how we can create a class. So let's say I define a class. So I have to define a class using the class keyword, and then you can write the name of the class, something like price. Okay, and then again colon mark and then pass. So if I do like this, what will happen is, even if I don't create any content inside the class, it will not throw an error, it will execute, because we are using this pass method. Now what we will do is, we will create some instances of the class. For example, we can do something like this. So if I have to create an instance of a class, so this is how a class instance is created. So what is price underscore p? Price underscore p is the object of class price. Okay, and within this object we can define various attributes. So price underscore p dot a is a variable equal to 20,000. Price underscore p dot b. This is another variable which is 10,000. And price underscore p dot brand equal to ABC. So now I have created an empty class, and inside that empty class, I have actually created three variables using this object notation. Okay. Now, if I print this particular sales price P, okay, if I print this price P, what will happen? It will say it is an object. So this price P is an object. Now, if I have to print the values, all the values out of it, then what you can do is you can do print object values are dot. You can use format like this. So, like this, you can create various instances of the class. So this is one instance. We have to print it the same line. Okay. We have to give the placeholder. Like this. So like this, you can create in one instance. I have created the one instance of the class. Similarly, you can create another instance of the class. So now you can create price underscore q is equal to price. So this is another object we have created. So we'll just copy paste this and change the values. So here you can copy. So price underscore here it will become q. Here become again q. This is again q. So here you can change the values. It will be q and q. So here if you see we have created a another price variable, another price object. So here the values are different. So like this, a class is a blueprint of object or instances that explain certain attributes or behavior. I can like this. You can create n number of objects. Now what is happening over here in this particular case? When you are creating a class, you are actually initializing the variables separately. But what if you want to initialize the variables uh, as soon as the class is created? So to set the to set the class variables automatically, we can use the init method. Init stands for initialization. So we can use the init method as well. So we can do class price and here we can define init method, and you have to use double underscore init double underscore, and the first parameter is called as self. Now what is this self parameter? So self parameter actually refers to the current instance of the class, and it is used to access the variables that belongs to the class. It can be referred with any name, but you can use self as that is preferred. And here we have a comma b comma brand. These are the three values which will be initialized. So self dot a is equal to a, and self dot b is equal to b, and self dot brand is equal to brand. So what we are trying to do is, as soon as this we create any object of this particular class, all these values will be automatically initialized. Now let's say that if I create a variable price underscore a is equal to price. So when I'm creating this price underscore a object of class price, I can pass these three parameters, which is 10,000, comma. Yes. So these are the three values. Now I can immediately print it. Earlier, what we were doing, we were initializing the values one by one. But in this particular case, we are initializing the values automatically. So as soon as this object is created, it will initialize the values automatically. And that is the use of initialization method. So the price underscore a object values are, you can write three placeholders, dot format, like this. It will print all the values of that. Like this, you can create multiple objects and you can work in that fashion. So this is a single class with no variables. Initialization, you are initializing the variables after the creation of the object. But in this particular case, what you are trying to do is you are trying to initialize the variables automatically. Now, what you can also do is you can have methods inside the class. So, same class, if we copy this one, you can initialize the method inside the class. Make sure you take care of the indentation part. So, here we are coming out of this initialization method, and we are creating as a method the multiplication. And here we are passing the self parameter. So self parameter, when we are passing, it will refer to the self objects of this class. So now, what if I have to refer to A, B, and brand? Let's say I have to multiply A and B together. What we can do is we can do total is equal to self dot A into self dot B, like this. So inside a method using the self parameter, I am referring to the variables which are creating inside the init method. And here I can return the value, return total. So like this, it is returning the total values. Now, if I run it, so here your class is created. Now, if I create an object of this class, so let's say that Yes, and calling the creating the object. Now what I can do is using this object, I can refer to the method inside the class. So the price underscore b, like this, and you can give the placeholder for total as well. Like this. So hope it is clear, and then you can use the format method. You can just copy it. This you can change it to object B. And what else you can do is once it is here, then you can call the method as well because you have given a placeholder, comma, like this. So run this. Sure. Price underscore B. So here you can see that the price underscore B object values are A, B, and brand, A, B, and brand, and we are calling this method price underscore B dot mul, which is multiplication. So it will multiply these two object values, which is nothing but 40,000 and 2,000. So it is this value. So like this, you can create a init method inside a class, and you can also use a method inside a class, and you can refer to that method using the class object. Now next thing is, now let's say that we want to write a very simple program to calculate the surface area of sphere in class. Surface area of a sphere. So let's say that we define a class sphere. And here we have to pass only one parameter, which is radius. So we can do self dot radius equal to radius. Okay, and we can define the method which is surface area, and then we can calculate the surface area for this one. So area is 4 pi r square. So we can calculate area is equal to 4 into 3.14 into self dot radius. Like this we can do. So 4 pi r square is the, and then you can return area. Now we create an object. We can create an object of this class. Sp underscore area is equal to sphere 20, and we can print the values. Print the area of the sphere is dot format. What we are trying to do over here is we are creating an object for a sphere class, and for this class we are actually calling the method which is present inside the class. So when we are creating this object and passing this 20, the initialization is done automatically using the init method. Now I am just calling the surface area method that will print the area of the class. So what is the area? It is a small s. Small s. Okay, so here you can see the area is 5024. So like this, you can play around with multiple methods and multiple functionalities. And we will see one more example. Today we have less audience. Maybe we will wrap up quickly, and we will have more detailed session tomorrow. So you can go through this. So here what we have done is we have created the calculated the sphere of the surface area of a sphere. Now we will check whether a year is leap year or not. So there are various functionalities for that. Let's see a program for that to check whether the year is leap year or not. So for this one, program to check if the year is leap year or not using class. What we can do is we can define a class leap, and then we can use the init method to initialize the year parameter. Because we need to check year, so it will be single input. We can do self dot year is equal to year. Now we will define a function to check whether this year is leap year or not. So we can do def leap underscore check self. So when the year is leap year, when it is divisible by 4, so there are a couple of conditions for a leap year. So if the year modulus of 4 is equal to 0 and self dot year percentage 100 is not equal to 0. So when the modulus of when a particular year variable is divisible by 4 and when it is not divisible by 100, then it is a leap year. And there is one more condition, else if self dot year percentage 400 equal to 0. If the self dot year percentage 400 equal to 0, then also it is a leap year. Okay, or else it will return not a leap year. Like this. Let's say if I have to check if the year is leap year or not, I can create an object. So now we can print the year is, give a placeholder, use the format method, like this. So what is happening over here? If the year is divisible by 4 and it is not divisible by 100, then it is a leap year. If it is divisible by 400, then also it is a leap year, else it is not a leap year. Like this. There is some error. So here it shows that the leap underscore check. Why it is showing none? Let me just check. Percentage 4 equal to 0 and percentage 100 not equal to 0. I think the program is correct. Let's try with some. So it is showing that year is a leap year, like this. Um, so in this way, you can check whether the program is working or not. So we'll kind of stop here. Today we have very short session because we have less audience. Maybe tomorrow we'll have full session and we'll see couple of more OOPS concepts, which is abstraction, encapsulation, inheritance, and polymorphism. So we'll be seeing all these OOPS concepts tomorrow, and please do revise all the sessions because once the Python is completed, we'll be starting with exploratory data analysis and the machine learning concepts. Okay, so let's connect tomorrow. Thank you.